Modified Gaussian integral xii. So this is the 12th video on the series of modified Gaussian integral. Before this we have solved problems like integral from 0 to infinity of e to the power minus lambda w of x whole square dx, or let's say replace this by ln of x. Also integral from 0 to infinity of e to the power minus sin h inverse x dx, and many more. Yeah, you can check these videos on the playlist linked in description, or also I will attach over here. Fine. Now let's move on to this problem. How do we solve this? Of course, the way to begin is to let substitution y equals to cos h inverse x. Yeah. With that substitution, we get cos h y equals to x. Now let's just deal with the indefinite integral first, and then later on we'll deal with the definite integral. So this will be integral of e to the power minus y square, and then this will be sin h y dy is equals to dx. Yeah, that's why dx equals to sin h y dy. Yeah. Now I can write sin h y as the definition of sin h y is e to the power y minus e to the power minus y by 2 dy. Yeah. Now take the 1 by 2 out, and this will be integral of e to the power minus y square plus y minus e to the power minus y square minus y dy. Yeah. Now after this we try to complete the square over here. If we try to complete the square, it will be e to the power minus of y square minus y plus 1 by 4. Sorry, 1 by 4, and then minus 1 by 4. Similarly, minus of e to the power minus y square plus y plus 1 by 4 minus 1 by 4 dy. Okay, now minus minus multiplies in this minus 1 by 4, so we get e to the power 1 by 4. Take common and take outside. E to the power 1 by 4 by 2 integral of e to the power minus y minus 1 by 2 whole square minus e to the power minus of y plus 1 by 2 whole square dy. Okay. So now this is related to OR function. Yeah, you know the integral of e to the power minus x square is just OR function. So that's why this will also be OR of y minus 1 by 2 minus OR of y plus 1 by 2. Yeah. Now because y is cos h inverse x, let's substitute that. We get the integral to be OR of cos h inverse x minus 1 by 2 minus OR of cos h inverse x plus 1 by 2. Yeah. And note that this is to be evaluated from 0 to infinity. But first let's check if this indefinite integral is correct or not from alpha. Okay, so basically wait, there's some error. Okay, so there's some error, and the error is because over here this is not just ORF. This integral is actually root pi by 2 times OR function, and I made the mistake over here. Sorry for that. Yeah. And is there any other errors too? Looks like there are. ORF of 1 by 2 minus cos h inverse x. ORF of 1 by 2 minus cos h inverse x. But if is there minus taken out common? Oh, okay. So here the minus is taken out as common. Yeah. Okay, we see that. So for that, how can we get this answer? For that, we use the property of oddness of OR function. Basically, ORF of minus x is actually minus ORF of x. Yeah. If we use this property, this will be minus of or 1 by 2 minus cosine inverse x. So then take minus common, and then root pi by 2 e to the power 1 by 4 by 2, and then this will be orf of 1 by 2 minus cosine inverse x, and minus is already taken out as common, and this is also a plus now. Okay, I think this is the answer over there. Yeah, cosine inverse x plus 1 by 2. Okay, is this the answer now? Orf of 1 by 2 minus cosine inverse x plus orf of cosine inverse x plus 1 by 2, and minus common out 1 by 4 fourth root of e. Yeah, this is the answer. Now let's evaluate the finite integral. So for that we need to use the logarithmic definition of cosine inverse x. We know that the logarithmic definition of, the formula of cosine inverse x is ln of x plus root under x square minus 1. Yeah. Now if we try to find cosine inverse of 0, we get ln of square root of minus 1. Sorry, ln of square root of minus 1. Yeah, we know that square root of minus 1 is I, so we need to find ln of I. Now the principal value of this expression is I pi by 2. That is because its principal value we can write I as e to the power I pi by 2. Yeah, though there are others as well, basically e to the power I pi by 2 plus 2 pi as well, but the principal argument is this, and we can only consider this for the sake of simplicity, and so this will be I pi by 2. Yeah, and cosine inverse infinity is ln of infinity, so that's infinity. Yeah, now we will use these values to evaluate. So this will be minus root pi e to the power 1 by 4, and this will be orf of at infinity, this is minus infinity, and this is okay, and this is orf of plus infinity. Yeah, and then minus, this is orf of 1 by 2 minus I pi by 2 minus orf of I pi by 2 plus 1 by 2. Yeah, and now we know that since orf is odd function, these two will cancel each other out. Yeah, because both of this is minus 1 and this is 1, and use minus sign over here. That gives us root pi by 4 e to the power 1 by 4, and this will be orf of 1 by 2 minus I pi by 2 plus orf of 1 by 2 plus I pi by 2, and that's the answer. Let's check from the alpha. Root pi by 4 fourth root of e, orf of 1 by 2 minus I pi by 2 plus orf of 1 by 2 plus I pi by 2, and yeah, that's the same answer. So this was it to talk about the flow of the solution. We first made use of substitution, and then computed square, used definition of orf, and back substitution, used the logarithmic definition of cosine inverse x, and then simple cancellations using oddity of orf function, and we got the answer. So that was it. Hope you enjoyed this video. Also check other videos on modified Gaussian integrals, but all of them are pretty awesome, and look forward to seeing you in the upcoming videos too.